The next session will cover UV extraction. Basically, what are the actual steps needed to extract UV information to be able to modulate certain rendering parameters or shading parameters in the render tree. Actually, the way things are available is that every object can have projections which imprints UV information, and those UV information can be used to actually map an image over the surface of the object. So as you can see here, we have sets of UVs with an image, and that will actually position the pixel over the surface to be able to render it. Now let's take a look at it. Is how this shader basically works. Well, that's quite simple. This shader needs to have two type of information. It needs to have the UV information at the intersection point, and the second one is the actual image, where it needs to use the UV to be able to pick up and do a lookup inside the image to be able to extract the precise color value, color map inside the actual texture to be able to shade the surface. So now what we're going to do is actually recreate this shader from scratch. So I'm going to actually discard this shader right here. I'm sorry. And build my own image node shader here. The first one is the actual texture space generator. These shaders are designed to go and extract the UV information that was provided onto the object and make it available as a vector color. So whenever it's yellow, it's really a vector type color. So if I connect it directly to the surface, obviously this will create a very funny image, which is actually mapping the UVW to red, green, blue. So you get this kind of shading, and that actually represents the actual UV information onto the object. This shader has an option to select what UVs it needs to extract right here. By default, the shader can have built-in repeats. So obviously, if you do this, you'll start to create these UV repeats information. For this purpose, for this demonstration here, I will not use repeats. Now what we have to do is we need to use this UV information and look up into an image. So let's go under the map lookup here and pick the image lookup. If I disconnect this shader right here and connect the actual map lookup directly, you'll see that it gives a constant color. The reason why it gives a constant color is simple, because the actual coordinates here are basically not varying over the surface of the object, but more or less being constant. So if I type, for example, 00, means that it's going to look up the actual color right here, lower left, right here. If I say, for example, 0.5, 0.5, I should be getting some sort of a green blend with the two. So let's add a little bit more, like 0.5, so I'll go more like towards here. So I can actually use this to look up the actual color. For example, if I were to put an expression on this, then I would, as I move the object in position, for example, I could say whenever it's at the lower left corner, for example, the center of the world, you'll get some kind of red, and if you move it like 10 units away, you get more white. You can actually start to use that expression thing that I showed in previous lesson to drive this shader. Now what we want to do is we really want to take this shader here that looks up the UV and connect it to drive the coordinate. Now as you can see, it's taking this image. I'm going to go and actually change it to use the actual ClubBot image. Voila. Now we get exactly the same thing as the image shader. The difference here is that, well, first thing is now we do have an access to the UV information here, so we can actually start to apply some funny math and operation onto this UV information. So let's go under the actual math vector. The reason why these things are named vector scalar, it means that it will take vector information, x, y, z, UVW, and output a scalar type information. Let's say the distance, or let's say, for example, the length of the actual vector, and so stuff like that. Vector means it's going to take, let's say, two vector information and add it up or subdivide it or multiply it, things like that. In this case, I want to use vector because I want to modulate the vector. So I'm going to connect this one to input 1 and connect this one to input 2. Now it goes to black. Well, that's okay, that's normal. By default, it will negate the actual input vector. So it will basically take the UV information and make it negative value. So what I'm going to do is just use scale here and make it 1. So now I take the vector input 1, which is this one here, and multiply it by this one. So if I do 0.5, I'm actually doing some sort of scaling here. So I'm scaling the UV here. Obviously it's not really useful, but the other type of stuff you could do, let's say vector input into plus vector input 2, and that will allow you to do offset. So you can actually start to shift the UVs without actually needing to edit the UVs in the texture editor. And this is done at render time, so it has basically no memory cost. It's very fast, very efficient, and will allow you to do very funny effects. Now what I want to do here is actually show you that this matte vector can be applied, but now I want to, let's say, perturb the UV information. So let's say, for example, I use a another image lookup, for example, right here, and I connect, let's say, this thing to vector 2. Now I'll be copying the red, green, blue to X, Y, Z, and let's move this thing here and connect this one directly here, coordinate. So now what I'm doing is I'm taking the image, the actual RGB value, and use that as an offset here. So obviously if I go here and pick a different image, for example, let's go in the exercise sample and pick, let's say, this. Now I could create very funny, effect like this, and it used the actual Chrome image as an offset map to offset the UVs, and that offset will basically be used to look up into this image right here. So you can really create very advanced effects quite rapidly with this technique. Now let's actually getting rid of this render tree right here, and let's go back to another flavor of what we call UV perturbation. So let's go under Node and go under Texture Space Controller and use 3D Warp. The 3D Warp is designed to take a position, for example, or let's say a UVW, and actually perturb it such that it will create this very wobbly texture. So as you can see now, I'm actually creating this, very noisy texture. Well, actually it's not really noisy, but let's say perturb. It's a little bit better if you put it on a grid, for example, or something that has a planar projection. But these are the type of stuff that you can do. So let's save this scene, and I invite you to go to the next session that will show you how to take these UV perturbation techniques to the next level. Thank you.